Hey guys, I'm going to be teaching you chapter 10.4 Ellipse. My colleagues Cody Wu, Bradford Yao, Kevin Wang, Justin Quach, and John Lee couldn't be with me right now, so I'm going to teach you guys it. So what is an ellipse? Well, I don't really like reading this long information, so I just think of an ellipse as like the orbit of planets or like a football. Here's what a horizontal ellipse look like and vertical ellipse. The horizontal ellipse, what you're gonna want to note is that the A is on the x-axis and the A for the vertical ellipse is on the y-axis. So here's some stuff you need to know. Okay, again, I don't want to read this, so I'm going to cut some stuff out. All right, yeah, just for you guys. The standard form of the equation of an ellipse is the center, which is h comma k, and the major and minor axes, which is 2a and 2b, respectively. And the important thing you want to know is a is larger than b, and b is larger than 0. So here's what it looks like. This is a horizontal one, and this is a vertical one. There's also this thing called a foci. What you're going to want to do to find that is you're going to want to take a squared minus b squared, and that's c squared. And the distance from the center to the foci is c. So if you want to plug in 0, 0 for the center, then you just do that right here, and this is what it looks like. There's one more formula you should know, which is the eccentricity, which is equal to C over A. All right, let's do our first problem. The vertices plus or minus 6, 0, foci plus or minus 2, 0. So what you're going to know is that the vertices, the x value is on the plus or minus 6 is on the x side, which means that it's going to be a horizontal ellipse. First thing you're going to want to do is you want to find the center, which is going to be the 2 points of the vertices added to each other divided by 2 as a midpoint theorem, and that equals 0. So the y is already equal to 0 in both points, so you know that the center is going to be 0, 0, which means that you can use this formula for it. Next thing you want to do is you want to look at the vertices. Well, it's plus or minus 6, and that means it's 6 units away from the center, which means that a equals 6. And c, on the other hand, would be 2, because it's plus or minus 2 points away. Then you plug in the equation to find b, and b squared comes out to be 32. Before you square root it, just take a look at this equation over here, and you notice you just plug it right in, and you just do that. You get this equation, simplify it, boom, bam, bam. You get simple equation, clean. I like it. Next equation, you're going to look at 5x squared plus 3y squared equals 15. You're going to divide both sides by 15, so you get a standard form. And then you notice, okay, well, it could be this problem. It could be the horizontal one because a squared and b squared fits, but it's not because a squared has to be bigger than b. Okay, so it's not going to be this one, and it's going to be the other one instead, the vertical one. You'll also notice that, wait, from this equation, there's nothing next to it, so it's got to be 0. This answer is 0, 0. And from the equation as well, you can also take that a squared equals 5, b squared equals 3, take into account the formula, and you get c squared equals 2. So from this, you can see that the center would be, since it's on the y side, since it's a vertical ellipse, you'd add the foci, the c number, to the y side, which would be plus or minus rad 2. The equation is k plus or minus c. So you'll see in the next slide as well. If you keep going, it's the same for the vertices. Since the y-axis is more dominant, you're going to want to add the a to the y side. And you get the eccentricity formula as well, which is c over a, which is equals rad 10 over 5. All right, next one. This is a big question. So you're going to want to, first thing you want to do is you're going to want to figure out what it looks like in standard form. So you can do this by completing the square and factoring like terms. Then, after you get the clean equation, you can plug stuff in because you know now that the a is bigger than the b, so this is the only formula that works. And you know it's not a circle because because in a circle, a and b have to be the same. So now you get the center. So the center would be 4, 3. And the next thing you want to do is you want to find out a and b. So a is 100, the square root of 100, because it's a squared. And b is going to be the square root of 20, which is also 2 over rad 5. So then you can find the foci, which is the distance between or the foci point, you can find distance from the center, which is c, and you just plug everything in. You get c squared equals 8, which is c equals 4 rad 5. And from this, you can start plugging in the points of the vertex. Well, you know the vertex is going to be on the x-axis because it's a horizontal ellipse. So all you do is you add h plus or minus a. And a, in this case, is going to be 10. So you get the vertices 14, 3 and negative 6, 3. You also can do the same for the foci as well, h plus or minus c, k. And the reason is because the foci always goes onto the dominant side. You saw in the last problem it went onto the y side, well, this time it's on the x side. So you get 4 plus or minus 4 rad 5, 3. The next thing you want to know is the other vertices, the co-vertices. This you can find by doing h, comma, k plus or minus b. And b in this case is 2 rad 5, so it's 3 plus or minus 2 rad 5. And the eccentricity is the formula again, where it's like E equals C over A. It's easy, you just plug it in, but it's easy. And then when you sketch it, it's going to look something like this. And that is 10.4. Thank you so much for listening, and I hope you have a great day.